Good morning. In this video, I'm going to talk about the features of a vertical hyperbola. So you should have just watched the video on horizontal hyperbolas, and you're going to notice a lot of similarities. Again, make sure you have a notebook out and you're taking excellent notes. You're going to want to refer to these notes when you're doing other problems. So similar to last time, we're going to look at the standard form, the center, the vertices, the co-vertices, the focus points, the transverse and conjugate axes, the slope of the asymptotes, and the meaning of A, B, and C. So the first thing we want to note in a vertical hyperbola is that the equation for standard form, and you may have guessed this already, is y minus k quantity squared over a squared minus the quantity x minus h squared over b squared equals 1. Okay, a couple things to point out. If I'm, that should be an a squared. If I'm starting with y, think of y as the vertical axis. That's a vertical hyperbola. A squared is always going to come first in any kind of hyperbola. So at least that kind of makes sense, right? You always have a squared, then you have b squared. So if it starts with y, it's vertical, okay? Again, note, I need to have a minus sign here. If this were a plus sign, this would look like an ellipse, okay? So that is the standard form. You may have also guessed that to find the center, it's also going to be HK. That seems like it never changes, right? I'm gonna use HK. So that's H and that's K. They're just in reverse order, but HK is still my center. Okay, so now I'm gonna draw a picture and we're gonna show where all these other points are. But if I have a vertical hyperbola, what that means is that the parabolas that make up the hyperbola are gonna open up and cross through the y-axis. And it kind of looks vertical if I look at it from far away. So this is a vertical hyperbola, okay? And many of the same points apply. So here and here, this is going to be a vertex. This is going to be a vertex. And you may have guessed that the letters are going to be the same letters. So to indicate a vertex, this is going to be the point 0A, right? Because A is always talking about the vertex. This is going to be the point 0, negative A, all right? Then you may have also guessed that here's my center. Now this is clearly not drawn to scale. That's HK. And the focal points are in a similar position. They're going to be inside each of the parabolas. So this is a focus point. And you may have also guessed that that's going to be labeled 0C, right? C is always associated with a focal point. Here's another focus point. And this is the point 0, negative C, okay? And just like the other horizontal hyperbola, you can imagine there's this imaginary rectangle, so to speak, that I could draw here. And again, this is totally not drawn to scale. I kind of screwed this up. But nevertheless, these 2 points here, which would be like the midpoint of this side of the rectangle, these are going to be the co-vertices. So this is a co-vertex. And you could probably guess this is called negative B, 0. I'm just assuming the center is 0, 0, by the way, just for the sake of argument and to make things easy for now, okay? And then here, so HK is there. This is another co-vertex. And this is the point B0. So sorry about that. That HK means this point here, it's the center. All right, so all of the same points as last time. Again, there are going to be 2 straight lines that are serving as asymptotes, and the branches of the hyperbola are gonna approach those asymptotes and never touch them, okay? So let's talk about the transverse axis. Remember, transverse sort of means to cross through. That's how I always think about it. So in a vertical hyperbola, the axis that crosses through the actual hyperbola is the y-axis in this case, right? So the y-axis is my transverse axis, okay? And that would mean that the other one is my conjugate axis. So if I look at the x-axis here, the x-axis is my conjugate axis. And this is just terminology to help you draw, okay? Now, interestingly enough, the slope of the asymptotes, what's interesting, slope is gonna be denoted by m, and there's gonna be plus or minus, because you can see I have one positive slope and one negative slope with my asymptotes. Now I have to think, okay, slope is rise over run, right? Change in y over change in x. At this time, the A is on the vertical axis and B is on the horizontal. So to find the slope of these linear asymptotes, it's gonna be plus or minus A over B. All right, now again, just a quick reminder that all the other letters represent the same thing. So if I'm looking for equations for the foci, okay, it's still c squared equals a squared plus b squared. Again, notice the slight difference from the ellipse formula. There's a plus there for the hyperbola, which means c equals plus or minus the square root of a squared plus b squared, okay? And as always, a, b, and c are gonna mean the same thing. A is still going to be the distance. Can you guys see that? Okay, distance from center to the vertices. Okay, so distance from the center to the vertices, there's still A. B is going to be the distance from the center to the co-vertices, just like before. Okay, and finally C, just like in the other video, is going to be the distance from the center to the focal points, or the foci. So everything is the same in terms of A, B, and C. It's just located vertically. All right, so I hope that helped a lot. Make sure you have excellent notes on this and that you have all your diagrams written out. I also have a hard copy of these notes on Schoology. So thank you for watching this, and in the next video, tomorrow, I will work out numerical examples of finding all of these points. So as always, email me with any questions, and good luck.